The solar system is a vast and wondrous place. At its center is our star, the Sun. Around this star, many celestial bodies orbit. Among them are 8 major planets. The planets closer to the Sun, like Earth, are generally rocky. Those farther out, like Jupiter and Saturn, are primarily gas giants, and each planet is a unique world, a testament to the diverse processes that shape cosmic bodies. We study these worlds to better understand our own origins and our place within this grand cosmic neighborhood. Exploration fuels our curiosity and expands our horizons. Uranus holds its position as the 7th planet from the Sun. This great distance means it is very far from us. It resides in the cold outer reaches of the solar system beyond the majestic rings of Saturn. Because it is so remote and dim, Uranus is not easily seen with the naked eye. It was the first planet to be discovered with the aid of a telescope. This momentous discovery occurred in the year 1781, forever changing our map of the solar system and revealing that our planetary family was larger than previously imagined. Uranus is classified as an ice giant. This makes it distinct from the rocky terrestrial planets. It's also quite different from the gas giants, Jupiter and Saturn. Ice giants are characterized by their composition, which includes a significant amount of heavier elements than hydrogen and helium. These planets contain what astronomers call ices. These ices are not just frozen water as we know it on Earth. They are volatile compounds like water, ammonia and methane, existing under extreme pressures and temperatures deep within the planet. The discovery of Uranus was a significant event. It literally expanded the boundaries of our known solar system. Before its identification, humanity believed Saturn marked the outer edge of the Sun's planetary family. William Herschel, the astronomer who found it, initially mistook it for a comet or a star. However, continued observations by him and others soon confirmed its true nature. It was a new planet, a distant and mysterious member of our Sun's retinue, waiting patiently through millennia to be welcomed into our understanding of the cosmos. Uranus embarks on an incredibly long journey around the Sun. A single Uranian year, the time it takes to complete one orbit, is equivalent to about 84 Earth years. Think about that. If you lived on Uranus, you would experience far fewer birthdays in a human lifetime. Its distant orbit also means it receives much less sunlight and warmth compared to Earth. Consequently, Uranus is an exceptionally cold world. The sunlight that reaches it is faint and diffuse, a pale imitation of the bright star we see from our terrestrial vantage point. The most extraordinary characteristic of Uranus is its axial tilt. The axis around which a planet spins is usually tilted somewhat relative to its orbital plane. Earth, for example, has a tilt of about 23.5 degrees, which gives us our seasons. Uranus, however, is tilted by an astounding 98 degrees. This extreme inclination means that Uranus essentially spins on its side as it orbits the Sun. No other planet in our solar system exhibits such a dramatic sideways orientation. It is a true oddity among its planetary siblings. This unusual sideways rotation has profound consequences for Uranus. Instead of spinning like a top, it rolls along its orbital path around the Sun. This extreme tilt leads to the most bizarre and extreme seasons imaginable in the solar system. For a significant portion of its long orbit, one of Uranus's poles points almost directly towards the Sun. This pole experiences continuous daylight for many Earth years, a summer lasting about 21 Earth years. Simultaneously, the other pole is plunged into complete darkness for an equally long winter. These Uranian seasons are unlike anything we experience on Earth. Imagine a summer where the Sun never sets for 2 decades, followed by an equally long period of perpetual night. During the spring and autumn periods on Uranus, which also last for many Earth years, the Sun would appear to rise and set more frequently, though still in a very different pattern than we are used to. Scientists speculate that a massive collision with an Earth-sized protoplanet billions of years ago might have knocked Uranus onto its side, causing this unique and dramatic tilt. Uranus is a giant compared to Earth. It is approximately 4 times wider than our home planet. To put it in perspective, if Earth were the size of a cherry, Uranus would be more like a small grapefruit. Despite its considerable size, Uranus is actually less dense than Earth. This is because it is not primarily composed of rock and metal like the terrestrial planets. Its designation as an ice giant hints at its bulk composition. Nevertheless, its total mass is still more than 14 times that of Earth, a truly substantial world. The term ice giant can sometimes be a source of confusion. The ice is thought to make up a large part of Uranus's interior and not solid in the way we typically think of ice. Deep within the planet, materials like water, methane and ammonia exist as hot, dense fluids. They are subjected to incredibly high pressures and temperatures. These extreme conditions prevent them from forming conventional solid ice. Instead, they form a kind of superpressurized slushy ocean or mantle beneath the planet's gaseous outer layers. The atmosphere of Uranus is primarily composed of hydrogen and helium. These are the two lightest and most abundant elements in the entire universe. However, a crucial ingredient in its atmosphere is methane. This methane gas plays a vital role not only in its atmospheric dynamics, but also in giving Uranus its distinctive appearance. Unlike Earth, Uranus does not possess a solid surface. It is a world of swirling gases and exotic pressurized fluids, a far cry from our familiar terrestrial landscape. There's no place to stand on Uranus. Uranus presents a beautiful, serene, blue-green hue when observed through telescopes. This distinctive color is a direct result of the methane gas present in its upper atmosphere. Methane has a particular property. It is very good at absorbing red and orange light from the incoming sunlight. The remaining blue and green wavelengths of light are reflected back out into space. This is why we perceive Uranus as a calm, cyan-colored sphere. From our distant viewpoint, it appears as a tranquil jewel in the outer solar system, belying its strange tilt and dynamic interior. Many people know Saturn for its spectacular rings, but Uranus also possesses a ring system. The rings of Uranus, however, are much fainter and considerably darker than Saturn's bright, icy rings. They are composed of relatively small, dark particles, making them difficult to observe from Earth. These subtle rings were actually discovered in 1977, somewhat by accident. Astronomers were observing Uranus as it passed in front of a distant star, an event called a stellar occultation. The star's light unexpectedly blinked on and off several times before and after Uranus itself blocked it, revealing the presence of these narrow, dark rings. Uranus is accompanied by a retinue of moons. At the latest count, 27 moons are known to orbit this icy giant. In a departure from the usual mythological naming conventions for celestial bodies, these moons are named after characters from the literary works of William Shakespeare and Alexander Pope. The five largest and most well-known moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Many of these moons are predominantly icy bodies, and some, like Miranda, show fascinating and complex geological features on their surfaces, hinting at past activity and internal processes. Much of our detailed knowledge about Uranus comes from a single brief encounter. NASA's Voyager 2 spacecraft executed a flyby of Uranus in January 1986. This historic mission provided humanity with its first, and so far, only close-up views of the planet, its rings, and its moons. Voyager 2 discovered several new moons, precisely measured its rings, and studied its unique atmosphere and complex magnetic field. In more recent times, powerful instruments like the Hubble Space Telescope and the James Webb Space Telescope continue to monitor Uranus from afar, revealing new details about its weather patterns and atmospheric dynamics. Studying Uranus is crucial for a complete understanding of our solar system. As an ice giant, it represents a distinct class of planet, different from both rocky worlds and gas giants. Investigating its formation, composition, and evolution helps scientists refine their models of how planetary systems come into being and develop over billions of years. It highlights the incredible diversity of worlds that can exist. Furthermore, as astronomers discover thousands of exoplanets orbiting other stars, many appear to be similar in size and nature to Uranus and Neptune. Understanding our own ice giants helps us to interpret and comprehend these distant alien worlds.